Hi everyone, my name is Fangyu Zhou, mentored by Professor Danny T.Y. Wu. I'm going to do the presentation on behalf of the research team. We do not have any conflict of interest to report. Our topic is the user-centered evaluation of a COVID-19 intelligent query system, the COVID IQS. We aim to help discover and accumulate knowledge in scientific literature to combat the pandemic. We use a user-centered evaluation and have 12 participants. We revise based on usability results found in the research. As an outcome, we got a development of an intelligent query system on the COVID-19 literature. As a research result, we got usability problems found in the research and personas and lessons learned for building such a system. In response to the COVID-19 pandemic, government agencies and leading research institutions in the United States created a COVID-19 open research dataset, which is called CORE19. It is a fast-growing data repository. This freely available dataset allows the global research community to learn the frontier scientific research and discover new knowledge from an aggregated central source. Researchers have primarily been interested in applying advanced informatic approaches, such as natural language processing and artificial intelligence on the core to propel knowledge discovery and bolster the fight against COVID-19. Several web-based tools have been released to facilitate knowledge discovery in the COVID-19 literature. For example, the LitCovid, COVID Scholar, and COVID-19 Primer. Our goal is to use human-centered AI approaches and create a usable, generalizable information hub for scientific literature. We use system development as a first step of the research method. We participated in the COVID-19 special track in the Text Retrieval Conference between April and July of 2020. Our team participated in it and made it to the leaderboard in round 4. Our team used Elasticsearch as a backbone and experimented with various combinations of ranking algorithms and indices. The medical concepts of a paper were extracted by MetaMap Lite. Our successful submissions were implemented in the COVID IQS, allowing users to perform keyword or ID research in term or concept query mode. We also use interface design in the prototype system. Firstly, we got user needs assessments after learning from the mainstream search engines, and we got a hypothesized prototype, and then we conducted a heuristic evaluation on that hypothesized prototype, and then revised it into a new one for the following usability evaluation. And this is the summary of the user needs and system requirements referring to the mainstream search engines. The main method we use in this research is the user-centered evaluation. We designed the study into 4 steps in 1 hour. Firstly, users are going to fill in a background survey collecting their ethnographic info, and then they went on a usability task. Firstly, they chose a topic among 99 topics and then generate their own keywords to search. And they performed 4 search tasks on the PubMed search engine and our IQS system. And then they fill in the usability survey, which is called System Usability Scale. And at last, they join in the semi-structured interview, which is an open-ended session to collect the feedback on the perceived usability issues. We recruited 12 participants in all from the University of Cincinnati College of Medicine. This is the prototype system being evaluated in the present study. In terms of the data collection and analysis, we used online collection as an overall tool. We use Google Form for background survey, WebEx screen and audio recording for the usability test and semi-structured interview, the Excel for usability survey, and the UC OneDrive to record all of them. In terms of the data analysis, we use summarized statistical summary for the background survey and usability survey. We got a SUS score which runs from 0 to 100, and 69 is the average score. For the usability test and semi-structured interview, we analyze it qualitatively with systematic review. Frequency is also calculated as references. We got results, and firstly, we got participants' demographics. So we got 12 in all, and all of them are clinical or medical researchers. Most of them are middle-aged group with a MD or PhD degree. And we also collected their literature search behaviors and preferences, including popular search engine, preferred type of publications, preferences on form of document saving. This is a list of our participant demographics. As a study result, we got a SUS score above average, which indicates good acceptability. But we also found two groups of people among those 12 participants, and 3/4 of the participants found the IQS quite acceptable. And we found 4 categories of usability issues. The first one is distinct user needs come from the user mental model. The prototype system did not fully consider the needs for specific user groups. And during the research, we found that a group of the user would like to find out mainstream articles in the search engine, while the other users would like to dig in the literature and find innovative ideas. We learned a lesson from it to pay attention to different roles in the whole user group. The second category is functionality errors caused by system functions. There's a mismatched mental models between the designers and the users, and this can result in the systems providing wrong functionality to the users. One good example is that the system provides the function to save all the articles you selected in the repository as a whole, while the users prefer grouping and annotate on the saved documents. A lesson learned from this category is to notice the usability issues, and these can help us to bridge the mental models and refine the system functionality accordingly. The third category is the suboptimal information display. It is about the information architecture, a less efficient and effective way of information representation and display is now in the prototype. And after the research, we found we should combine the presentation of abstracts and their key sentences instead of present them in separate sections. One lesson learned from it is to increase reading efficiency. And the category 4 is the implementation errors. Implementation errors are not intentionally designed and can be resolved technically. One good example is the PubMed identifier was misplaced by a document identifier. Fixing this type of usability issues before launching can significantly increase user acceptance towards the system. We also found user roles from the literature search. We also found the user roles in literature search from our research. There are 2 different groups of users from our quantitative and qualitative analysis. From the literature review, we also found a division of users of collaborative searching, which is managers and knowledge workers. And we finally found 3 groups of IQS users after qualitative analysis: administrator, expert, and principal investigators. And the administrator is more of a manager, and the expert and principal investigators are more of knowledge workers. We also found 2 different team structures, which is hierarchical team, having managers and expert at the same time, and equal collaboration containing mostly experts and principal investigators. We found in quantitative analysis that 3 users belong to group A, and they're mostly from the hierarchical collaboration and view the recruitment of team assembly as the most important step to solve the collaboration problems, while 9 others belong to group B. They are mostly from the equal collaboration and emphasis on knowledge discovery and hypothesis generation. This is the persona we found based on the semi-structured interviews. We found, these are the key findings of our research. Firstly, we developed the COVID-19 literature search engine with algorithm development and user-centered evaluation with 12 participants. We got a SUS score above average, which indicates a acceptance of the IQS system. And we found 4 categories of usability problems. And we found 3 different user roles and got lessons learned. One of those lessons is to conduct phased user-centered evaluation. The design and development of literature search engines supports the suggestions of user-centered evaluation, while the traditional way people evaluate collaborative search is the relevance of retrieved documents, but we support the usability improvement is more important. The second lesson we learned is to consider user roles and collaborations. From the mixed SUS score, we found 2 different roles, and it is also crucial to consider different social and cultural differences of the user. We also have limitations, for example, the sample size. We got 12 participants, which is a small sample group, but we can already find 55% of usability issues with only 5 participants. So 12 participants is far more enough to find out the usability problems. We finally found an unbalanced demographics. People are mostly male in their mid-career. So we decided to collect more user data after launching to engage diversity of users. There's also a test limitation. 3 out of 4 searching modes were tested instead of testing 4 of them. Time is limited, but we combined different modes to test, which compensate to the disadvantage of research design. In conclusion, we developed a COVID IQS system and learned its usability issues and got 2 lessons learned, as well as refine the IQS based on the findings. What we will do in the future is to collect and evaluate user data after rolling out the system to design for specific roles of users and enhance repository features to support collaborative information seeking. We will integrate COVID IQS into our clinical research informatics infrastructure to support the COVID-19 research planning in our institution. And we will further share the COVID IQS globally if possible. Thank you for your time. If you have any questions, please contact our corresponding author, Professor Jenny T.Y. Wu. We thank Ms. Chen Xin and Ms. Tianran Vicky Chen for their effort on interface design and heuristic evaluation. We also thank Ms. Anunita Natam and Mr. Rusvika Bu for manuscript proofreading.